Okay, after the preparation method, now we are going to start with the physical properties. Okay, so like this, if you study, then easy to remember. Only up to propanoic acid, only up to propanoic acid, they are liquids. Only up to propanoic acids, they are colorless, pungent smelling liquids. Okay, and C4 to C9, they are also liquid with goat's butter like smell. Okay, with goat's butter like smell. And from C10 to and above, they are colorless, odorless, waxy solid. Otherwise, simply you can remember about 10 carbon atoms, they will be solid. That means after C10 something or C9 something with COOH, above that they will be solid. If they are below the 9 carbon atoms, they will be liquids. What they will be? They will be liquids only, but either they will have goat butter like smell or pungent smell. Okay. Now solubility up to C4 only, they are soluble, and they will ask why they are soluble. Okay, what you have to write? Due to formation of hydrogen bond between the COH group and water. See, this is the water molecule. Okay, and this is the COH. So this is a hydrogen bond between the dotted line represent the hydrogen bond between them. Okay. So when you compare the boiling points of alcohol with corresponding carboxylic acid and alcohol, which is going to be higher? Carboxylic acids are going to have higher boiling point. What is the reason? Number of hydrogen bonds formed by carboxylic acids are at two different points. At how many points? Two different points it is going to form. Okay. See, this is one and this is another point. But in case of the alcohol, there will be only hydrogen bond, only one hydrogen bond will be there. Okay. So one hydrogen bond is weaker, two hydrogen bonds are stronger. Therefore, boiling point will be higher. What will be higher? Boiling point will be higher. Okay. So that is what the difference between the boiling point along with the reason. Next, melting point. So when you compare the melting point, you will find very different answer. What is that? See, melting point of 2n. 2n means even number. Okay, molecule with even number of carbon atoms. 2n stands for even number, and here it is odd number. Okay, here it is odd number. So even number and odd number, even number of carbon atoms are going to have higher melting point. But the question is why it is, either it should increase or it should decrease, but sometime alternating effect. First it will increase, then decrease, then increase, then decrease. Okay. So when it is structure they have seen, then they found the reason for that. Okay. Even number. Suppose hexane will have higher boiling point, but heptanoic acid will have lower boiling point. Again, octanoic acid will have higher boiling point. Nonic acid will have lesser boiling point. Okay. So why it is that I am going to show you in the next slide. Okay. See, next slide will show you the reason. Suppose if it is a even number, see here, alkyl group is on this side and carboxylic group is on the other side. Okay. So then packing can be exactly done, provide more effective packing. Okay. So here this is COH, alkyl group and alkyl group. But once it is odd number, okay, 1, 2, 3, 4, 5. 5 carbons are there. So when they are odd number, then it will be very difficult to pack them nearby. So there will be a gap. So once distance increases, okay, distance increases, then density will increase. What will increase? Density will increase. Once density increases, melting point decreases. Simply you can say effective packing is more in the uh, odd even number and less in case of the odd number. Therefore, due to ineffective packing, odd number carbon atom containing carboxylic acid are going to have less melting and boiling point. Is that clear to all of you? Now let's see the next point. Okay. So chemical properties, the very important and very only unique property of the carboxylic acid is it's acidic in nature. Question is why carboxylic acids are acid in nature. Okay. So that is because of the resonating structure. It is resonance stabilized carboxylate ion. Okay. So this is the carboxylic acid. So there can be resonating structures after loss of the H plus. Okay. This is called as a carboxylate ion. Carboxylate ion. Okay. So carboxylate ion is more stable. Therefore, it will try to lose the H plus. But acidic value Ka, dissociation constant Ka will be between 10 to the power of minus 14 to 10 to the power of, 10 to the power of minus 4 to 10 to the power of minus 9 only. Therefore, carboxylic acids are acid but weak acids. They are but weak acids. Okay. Melting and boiling point both we have seen. Solubility we have seen. Okay. Solubility up to 4 carbons only they are soluble. After that they are insoluble. Boiling point increases with increase in number of carbon atom. Melting point even number will have more melting point, odd number will have less melting point. And after C10 it is solid, before C10 it is liquids. Okay. So this is what the physical properties. And now chemical properties is carboxylic acids are weak acids. Okay. Now let us see the very important points now. Okay, next one is effect of substituent on acidic strength. Okay, definitely there will be one order, increasing order of acidic strength, decreasing order of acidic strength. Okay, so there are two types of group: electron withdrawing group. Electron withdrawing group disperse the negative charge on carboxylate ion, therefore stabilizing A. Okay. So suppose see this is taking out the electron from the carboxylate ion. Therefore, once it takes out the electron from the carboxylate ion, stability will increase, then acidic strength will decrease. So acidic strength will increase. Okay. So here if it gives the electron, already electron is there and it is also giving electron. So G releases electron, so then destabilizes. Okay. So when more electron also there, then also unstable, less electrons are also unstable. So perfect balancing is done when electron withdrawing group is there. Okay. For example, chloroacetic acid. Chloroacetic acid means C. So this is CH3, COOH is the acetic acid. And in this acetic acid, if we find that there is a one hydrogen is replaced now. One hydrogen is replaced with chlorine. So what it will do, it will pull up this electron towards it. Then there will be negative charge, there will be positive charge. So this withdrawing nature of the chlorine increases the acidic strength 100 times than the acetic acid. Acetic acid is weaker and chloroacetic acid is stronger because of the EWG nature. EWG means electron withdrawing nature. So more number of EWGs, more will be acidic strength. Okay. So that we will be doing some questions also. Then you will understand with clarity. Okay. Now let's see the next effect of substituent on acidic strength of the benzoic acid also same. We have studied in the aliphatic acid and the benzoic acid also it is same. So then for example, benzoic acid is stronger than the para-methoxybenzoic acid but weaker than the para-nitrobenzoic acid. Okay. What does it mean? See, let us take this as a benzoic acid. Benzoic acid means on benzene it is COH. Then para-methoxy benzoic acid. First let us draw the benzoic acid and which is the position Ortho, meta, para. Om Parameshwara. So para is here. There what I have to write? Ortho methoxy. OCH3. Then para nitro. Sorry. Then I will write it afterwards. In another structure I will write. Okay. This is benzoic acid. Now let us see the next one. So COOH, and here it is para nitro. So which is more? This is more, this is less, because this is ERG. What is this? Electron releasing group. What? Note down this ERG, electron releasing group. NO2 is electron withdrawing group. Okay. If you don't know this, what is withdrawing group, what is releasing group, just write in the YouTube, you write which chem, okay, and directive influence. What you will write, which chem, directive influence. Then you will get a video. Then you will immediately understand what is orthometa, what is EWG, what is ERG. So that you will come to know. Okay. So next, ortho effect. Very, very important. V to the power of infinity important. Okay. So among the isomeric substituted benzoic acid, ortho isomer is strongest acid irrespective of nature of substituent. Okay. So here it says that electron releasing group, if it is attached, then it should be weak. But here it is opposite. See, here it is the strongest one. So that exceptional behavior of strong nature is called as a ortho effect. Okay. Let it be any group. If it is present at ortho position, that is going to be the strongest acid. Okay. Irrespective of nature and type of substituent at the ortho position, always ortho substituted carboxylic acid will be more and more stronger. Okay. So acidic strength among the following acid is of the order. So because of ortho effect, orthobenzoic, and here methoxy, here para. Okay, because there is no EWG, ERG at meta position. EWG and ERG will work only at ortho and para position only. Okay, so this is what important order, that is ortho effect is very, very important. Okay, now let's see the next one. Okay, HVZ reaction is substitution of halogen on alpha carbon in presence of, if we carry out in the presence of phosphorus. This is also very important. That's why I am giving you so much caution about this. In presence of phosphorus, it will give you monohalo product only. Further substitution will not take place. Okay. And formic acid does not show HVZ reaction because there is no alpha hydrogen and alpha carbon also. Okay. HVZ reaction, I think it is clear. Number of moles of halogen consumed is equal to number of alpha hydrogens. So you should be perfect in finding out the number of alpha hydrogens. Okay. So I think all of you now understood. Now let's do the next topic. Okay. Next here, these are the reactions showing the acidic behavior. Okay. What is this? These are the reactions showing the acidic nature. First type of reaction. So acidic nature means what it will lose? Once I say this is acid, then it should lose the hydrogen. H plus it should lose. And in place of the H plus, the other element must be substituted. See, let us take here sodium will be substituted here. This hydrogen will be emitted as a half H2. This hydrogen is emitted as a half H2. First thing it is understood now. When a carboxylic acid reacted with sodium, then only this hydrogen will be replaced. There is no reaction on alkyl group. The reaction is only on the acidic hydrogen. That acidic hydrogen will be liberated as a hydrogen gas. Now this is the most simplest. Acid plus base. Acid plus base, what it will give? Salt plus water. Acid plus base, what it will give? Salt plus water. Okay. And this is, see here, two sodium are there, so it will react with the two molecules. Okay. So two RCOO will be produced. Both hydrogen and this oxygen will be liberated as a H2O. Okay. So I will write it here, then it will be simple to understand. This reaction, I am writing it here, RCOOH plus Na2O. Na2O. Okay. So these two hydrogens and this oxygen, what they will form? H2O. So one sodium will be attached here, another sodium will be attached here. Therefore, 2 moles of RCOONA will be produced. Okay, 2 moles of sodium salt will be produced. And next, very important reaction. What is its importance? I will tell you in the bottom. Okay. Then RCOOH plus NHCO3, sodium bicarbonate. This is used as a test. Okay. This is called as a sodium bicarbonate test. Understood? So people think that I will take a screenshot and I will go through the notes. Understanding from the notes and attending the video lecture, there is a lot of difference. Effectiveness will be almost 10 times. Suppose I am writing here only test, but how you will come to know what is the test and where it is used, that everything we will not be able to write. So that audio, visual and writing all must be there. So going through the only notes will not be helpful. I hope all of you will understand and attend the video lecture, not only notes. Notes is a secondary thing. Primary thing is attending the video lecture. Okay. So what is that lecture? I will tell you now. Okay. So there is a lot of difference in understanding in the lecture and studying from the notes. Okay. So once you go through the video lecture, make your own notes, then go through that. That effect will be different. Okay. So let us see, sodium bicarbonate test is used to test the presence of carboxylic acid. In the question, what they will give? They will give effervescence. CO2 is called as what? Effervescence. Gases will be liberated fast from the container. That is what called as effervescence. Whatever the terminology I am saying, that is all the previous examination terminology. Okay. So next, PbCO3. This is dry heating test. It is called as a dry heating test. So both hydrogens will be replaced by the lead and this will be formed as a lead acetate. Okay. So after this it is treated with the H2S, then PBS will be formed, which will be used in the qualitative analysis. That is also test, but in the qualitative analysis, which comes under the inorganic. Okay. Now ammonium carbamate. This is also functional group. What it is called as? Ammonium carbamate. Okay. Its name is what? Ammonium carbamate. Understood? Then calcium salt. Dry carboxylation test. This we have studied in the aldehyde preparation, ketone preparation. Okay. So many reactions I have written together so that you should not feel so many pages of notes. Notes are, it should be crisp and it should be concise, but you should be able to understand through that. Okay. So I think all of you now understood. Now let us say the next topic. Okay, so other subject you may be able to understand from the notes, but I don't think chemistry is effective. Okay, so now next here, reaction with ketene. See, what is the importance of this? Ket and ene. Okay, what is the importance I am telling you here? Ket and ene. Ket means ketone, ene means double bond. Okay, so both must be there. See, because of this C double bond O, it is ket. Okay, because of this double bond, it is ene. Therefore, it is called as a ketene. Is that clear to all of you? Now, when this reaction takes place, simply this hydrogen will be added up here. Then this oxygen will be making a bond here. Then this is the product formed. Okay. And every chemistry lecture is interlinked. Suppose you attended first lecture, second lecture, skipped the third lecture. If you attend fourth lecture, no use, because something related to fourth lecture will be included in the third lecture. So continuity and attending, while attending, making notes are only the success formula. Okay. Next, diazomethane. See, di means two, azo means nitrogen. Okay. Methane means one carbon. So this is the diazomethane. This also we have studied in the properties of aldehyde and ketone also. Okay. So there it was some other product, but here it is ester will be formed, but the limitation is that it is a methyl ester. Okay. What is methyl ester and what is normal ester? I am writing it here. RCOO dash. Okay. When this R dash is methyl, then it is called as a methyl ester. If R dash is ethyl propyl, then it is simple ester. Okay. So diazomethane is powerful methylating agent. If anybody is in requirement of methyl group, like blood donor is there, so blood bank. If anybody is in requirement of the blood, they will come to the blood bank and they will get the blood. So anybody is in requirement of methylene. Okay. Methylene means CH2 group is called as a methylene. So wherever methylene is required, immediately you will treat it with diazomethane, because nitrogen don't want to stay with the methylene, because nitrogen feels freedom when it is in gaseous state. So for that, whoever is asking, immediately it will give it to them. That's why it is called as a methylating agent. Is it clear to all of you? Okay, next, suppose you take screenshot and study. Will you understand with this notes? No. If you understand and write on your own from this, then it is going to be very effective. Okay. So next, reaction with alkene and alkyne. So here alkene double bond is there. When carboxylic acid is treated with alkene, this hydrogen will be moved here in presence of boron trifluoride, and this pi bond will be between oxygen and carbon. So this will be the oxygen and carbon. Okay. So RCO, oxygen, and single bond CH2, single bond CH3. This CH2 now converted into CH3. So this is the ester. Again it is what? Ester only. Okay. But ester is not methyl ester. It is some simple ester. Okay. Simple ester means alkyl group can be anything other than the CH3. Okay. It is simple ester is formed. Okay. Next, this is a ethylene. Then same way, if I heat it with any other than ethane, then same hydrogen will be attached here. This double bond will be attached over here. See, still it is ester only. It is also still ester only. Always ester formation will be taking place. But if you use the diazomethane, you will get methyl ester. If you use the alkene, then you will get the simple esters. Okay. Then if we use the ethyl acetylene, then one side double bond will remain active. And what is the reagent? Mercuric sulfate. Mercuric sulfate is the reagent we are going to use it. Is that clear? If you got any doubt, you can ask. There should not be any problem in asking your doubt. Okay, in the starting only I told you we are studying how many types of reactions. This is called as a retentivity. Okay, I told you we will study 6 type of reactions. And first reaction where hydrogen will be replaced, and second reaction where alkyl group reaction takes place. Okay, we have completed this one, HVZ reaction and acidic nature. Second, diazomethane, alkene and alkyne. Now the third type of reaction, wherever carbonyl group will be involved. Okay, what is involved? Carbonyl group. Okay, third reaction, third type of reaction we are doing, and after that some more important reaction. Last one is very very important, so don't forget to watch and be available till the last. Okay, so like there is a, I think some South Indian star, last punch manadaite. Okay, like that you should stay till the last reaction. Okay. So here four hydrogens are required. How many hydrogens are required? Four hydrogens. So who will replace? Who will give that four hydrogens? Sodium borohydride can give, or aluminium, lithium aluminium hydride can give. Okay. What they are? They are best reducing agent in the market. Okay. So whenever you want some hydrogen, you can ask whom? Sodium borohydride. Okay. So nowadays the shortcut trending, SBH means sodium borohydride. Okay. LAH means lithium aluminium hydride. So don't forget LAH is LAH, LiAlH4 only. Okay. So they are using shortcuts so that students should not be able to answer, and they can collect the more fees by joining them into the private colleges. Okay. So small information can land you up in the private colleges. Private colleges means lakhs of rupees. Okay. So LAH means lithium aluminium hydride. SBH means sodium borohydride. Okay. So what they are converting? Alcohol. Okay. So very simple reaction. Red phosphorus. This is my favorite reducing agent. It will convert anybody. Nobody is can save from the lithium, sorry, hydrogen iodide. All are converted to alkanes. All are converted into alkanes. Is that clear to all of you? So I will give you a simple question based on this. Just wait. Okay. Okay, next, in this we have changed our carbonyl group. What we have changed? Our carbonyl group we have changed. Okay, so carbonyl group is changed to alcohol in presence of LiAlH4 and sodium borohydride. In presence of red phosphorus, it is converted to alkane. Okay, this is the third type. Okay, I am writing it again and again so that you should not forget the reactions. Okay. First one is reaction is due to acidic nature or hydrogen. Second one is due to R. Third one is due to C double bond O. Okay. Now fourth one is due to OH. Now in all reactions we will be removing the OH. So once you know about the heading, then product guessing is easy. Okay. So dehydration, and P2O5 is a acidic dehydrating agent. Okay. So when you go to the shop and ask dehydrating agent, they will ask you want acidic or basic. So then you should not be in doubt. Okay. So acidic dehydrating agent. P2O5 is what? Acidic dehydrating agent. So dehydrating agent means which removes water molecule. Any substance which removes water molecule is called as a dehydrating agent. Understood? Now, if we use the P2O5, at least two molecules are required. How many moles are required? Two moles are required, and both will not give same thing. One will provide OH, another will provide hydrogen. So both will be formed as a H2O. Both will be formed as what? H2O. Now this is called as, this is what I told you in the very first or second lecture. They are all called as a derivatives of carboxylic acid, and its name is acidic anhydride. What is it is called as a acidic anhydride. Okay. So this is about the reactions involving OH group. Now let's see the next slide. So if I'm changing the slide, you should not change your slide in your mind. That should be permanent one. Okay. Next very famous reaction, everywhere you find it. What is that reaction? Very good, esterification. So this is a preparation of esters. So we will prepare esters in how many ways? By in the alcohols also, in carboxylic acid also. Always remember the reaction is proton catalyzed, that is acid catalyzed esterification. In the reaction, OH comes from the acid. Okay, this OH which is coming from OH comes from the acid and H from the alcohol releases H2O. This H2O contains. Okay, so in this H2O, OH will be coming from the acid. Hydrogen will be coming from the aldehyde. Okay, sorry, alcohol. Okay, so what is that? How the questions will be coming? That I am writing it here. Just wait. Okay. Now let's see the questions based upon this sentence. Okay, here next is reaction with phosphorus chloride. Phosphorus forms two types of chloride, trichloride and pentachloride. Trichloride and pentachloride. So once it is trichloride, you should make sure that 3 moles must be there. How many moles? 3 moles must be there. If it is pentachloride, you can understand here only 1 mole is there, but product is same in both of them. Here also RCOCl, here also RCOCl, and here H3PO3. These are different. Okay, trichloride 3 moles and H3PO3, and pentachloride 1 mole and HCl and POCl3. Okay, thionyl chloride is very important thing. What is that important thing? I will show you in the next slide. So this is in SOCl2. In SOCl2, this oxygen will be attached with SO and will form as a SOCl. So SO2 and H and 1 chlorine will come as a HCl and RCOCl. Okay. So I am writing the mechanism here so that you can understand easily. Now let's see the how to write the product easily. Okay. With tips and tricks. With tips and tricks. Okay. So R C double bond O H. Okay. Like this, if it is RCl, PCl3, you will write how many times? You will write 3 times. You will write how many times? 3 moles you will write PCl3. If it is 3, then you will write 3. Okay, POH3, sorry. So RCOOH you will write 3 times. And here PCl3, PCl3. Now you have to cut like this. Like cut, if you cut like this, then one chlorine will go and attach here, second chlorine will go and attach here, third chlorine will go and attach here. Okay, so how many moles are there? 3 moles of RCOCl is formed, and here HPO3, so we can write it as a H3PO3. Okay, this is a trick. You can easily write the product now. Now if it is pentachloride, if it is pentachloride, you need to write only once Fasak. Okay. PCl5. Okay. PCl5 you will write like this. PCl5 will write like this. Now it will cut like this. It will cut like this and it will come like this. Okay. Like this and like this. Then product is like this. RCOCl3, then POCl3, HCl. This is the third product. And second product. Third one is SOCl3, RC double bond OH. Okay, SOCl2. Sorry. Okay, SOCl2 you will write like this. Okay, so only once Fasak. Okay, so 3 product. What are those 3 products? RC double bond OCl plus SO2 plus HCl. Okay, this is the our answer. Is that clear to you? This is how to find out the product only once. Okay, I hope all of you understood now. Now let's see the next answer. Okay, next reaction. SOCl2 process is very, 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 very important. Okay. Why it is important? Because of some uniqueness you find. Okay. That uniqueness here I am showing you that already reactions I have explained with the tips and tricks. Now we are going to see the importance. In the reaction of SOCl2, all are gases. HCl is gas, okay, and absorbed by the pyridine and pure acyl chloride is left over. See here what is used? Pyridine is used. It will absorb the HCl and SO2 will be gas. So you will get the pure, okay? So you will get the pure acid halide. Then that's why this is most important method. Okay, now I think it is clear. That shortcut, don't forget, and with that you will be able to write the answer in one shot. Okay. Then formation of acid amides. Next reaction is formation of acid amide. Very simple. This we have already studied, I think. See, NH3 will add up here. NH3 plus 1, NH4. This is called as a carbamide. Okay. So this is amide, acid amide. Then if you remove the water molecule P2O5, just now I told you acid dehydrating agent, it will remove the H2O. Then RCN is formed and H2O will be left over. Okay. And hydrozoic acid, it is called as a schimidic reaction. So in this N3H, it is not NH3, it is not printing mistake. Okay. If I write NH3, that is ammonia. Okay, that everybody know, but very few people like the, sorry, ammonia. Very few people know that N3H is also there, which is called as a hydrozoic acid. So in the hydrozoic acid, simply sulfuric acid is also dehydrating agent. It will remove the water molecule. Then nitro N3 will be attached here. Okay. Again, if you add water molecule, then you will get the, then you will get what? Amide, and this CO and this oxygen will be removed as a CO2. Out of 3 nitrogen, 1 nitrogen is here, remaining 2 nitrogen will be emitted as a N2. This reaction is a modified version of the Curtius reaction. Curtius reaction, Schmidt reaction, almost same. Just small modification is there. Okay. Curtius reaction is used for preparation of amides only. Okay. Next one, reaction due to fifth method. Fifth reaction is reaction due to COOH group. Okay. First method, first reaction is decarboxylation. Decarboxylation means removal of CO2. So for that we will use soda lime. Okay. Actually we will call soda only NaOH. Lime is CaO. When we use both of them, it is called as a soda lime. The mechanism is this one. Here RCOO minus, first it is a ionic substance. RCOO minus will lose the CO2. Then this negative charge will be migrated here to form R minus. What is this RDS? RDX. It is not RDX, it is RDS. RDS means rate determining, S means step. Okay, rate determining step. This is the RDS. So on RH, R minus, this will be HOH. HOH, this H will be positive. So H positive will attach itself. This is a fast reaction. So rate of reaction depends on this one, and it is reversible in the, therefore to avoid that we will use the CaO. CaO will take out that CO2 as soon as it is formed, so that as per Lee-Chandler principle, if one of the product is removed, then it will be only in the forward direction. Okay. So RDS involves the formation of carboanion. Negative ion is called as a carboanion, and decarboxylation directly proportional to stability. If you are able to form stable carboanion, 1 degree carboanion more stable than the 2 degree least stable is 3 degree carboanion. This is the stability, reaction mechanism, we have studied this. Okay. Okay, next one is beta keto acids. So see here, this is a COH carbon. Now this will be the alpha carbon. Next to it, it is beta. On beta you have ketone. So simply just heat this, then CO2 will be eliminated. Okay, what will be eliminated? CO2 will be eliminated. Okay, beta keto acids will give the ketone again. Simply, the temperature must be between 100 to 150 degrees Celsius, where CO2 will be lost. So, best example is malic acid. Malic acid, already I told you the trick I told you, Ohm's gap. Okay, Ohm's gap, oxalic, malic is this one. Okay, malic acid, when just heated, it will lose this CO2. So CO2 is lost, then this hydrogen will be shifted here, acetic acid will be produced. Okay, now I think it is clear. Now let's go on to the next slide. Okay, next one, if it is beta gamma unsaturated carboxylic acid gives alkene. So what is beta gamma? Same alpha beta gamma identification is very simple. This is the functional carbon. This is alpha. This is beta. This is gamma. So between them the double bond is there. Double bond and triple bond are called as unsaturation. Okay. So simply on heating the CO2 will be lost. So this hydrogen is shifted here. Then what it is forming? Alkene is formed. You need nothing, just you have to heat. Okay. So this is the mechanism just they have shown. If it is having more number of carbons, then like this H2O will be eliminated and alkene is formed. Only CO2 will be liberated. Okay. So now I think it is clear. Alpha beta gamma will give you alkene, beta ketoester will give ketone. Okay, so these are the special cases. Further, you have to understand what is the next product after this. Okay, so that is what I am telling you. So note down this. Okay, now let us see the next one. Heating effect. Heating effect, there are some direct answers. Okay, if it is a alpha hydroxy acid, alpha means, see letter, I will write it like this, CHOH. This is OH is there. Now it is not called as alcohol. It is called as a hydroxy. So this is alpha hydroxy carboxylic acid. So in this one, 2 moles will be reacting. See, this is 1 mole of carboxylic acid and this is another mole of carboxylic acid. 2 moles of carboxylic acid react with each other to form water will be removed and this is called as a lactide. This is a functional group cyclic ester. Lactides are functional group which is called as a cyclic ester. Then beta hydroxy acid. So that was alpha hydroxy. This is alpha, this is beta. So if the hydroxy is there in the beta position, it will not form lactide. It will form alpha beta unsaturated carboxylic acid. Okay. So depending on the question, you should be able to identify the answer. These are the heating effect it is called. And gamma and higher hydroxy, if it is more than the third carbon, then cyclic ester will be formed. They are called as lactones. Lactides will contain 2 oxygens in the circle and lactones will contain only 1 oxygen in the circle. Okay. So this type of structure is called as a lactone. This is called as what? Lactone. Is it clear to all of you? Lactone and lactide, very important things. Okay, next one is Kolb's electrolysis. Kolb's electrolysis is used in the preparation of alkanes. Okay, and already in preparation of alkanes, hydrocarbon it is studied. In that, main question will be there, where anode, what are the things liberated at anode, what are the things liberated at cathode. Okay, so this you will remember, and as a shortcut again I am telling you. So these shortcuts you won't find in books, you won't find it in the net. Okay, you will find only at the chem. So don't forget to watch chem every day. It should be your life schedule. OH, H. Okay, OH and H. You will write like this. So 2 moles of carboxylic acid. See, one will be the KOH. Sorry, another will be, it will be KOH. 2 moles of KOH. This is the 2 moles of KOH. 1 mole of hydrogen. This is 1 mole of hydrogen. 2 moles of CO2. How it is? See, this is one CO2, this is another CO2. Okay. So these are the two CO2 products. Okay. And this will be the 2 moles of R. This is the 2 moles of R. So this is how you will remember the memory trick. Memory trick to remember all products. Okay. Not one product, and all product you can remember. Okay. Okay, next one is action of heat on heat or dehydrating agent on dibasic acid. Sorry. Dibasic acid means 2 COH group must be there. See here. First one is oxalic acid. Oxalic acid when heated at 200 degrees Celsius. As usual, it will lose CO2 and HCOH, but it is unstable. So it will further lose carbon monoxide and hydrogen. This is what malic acid, but hydrogen is there, but alkyl group is there, then it will lose CO2 and it will convert into monobasic acid. Okay, so they will undergo decarboxylation. What they will undergo? They will undergo decarboxylation. Okay, now let's see the next one. 1,4,1,5 dibasic acid undergo intramolecular dehydration. Two molecule. Actually, there is a bond here. Actually, print mistake. Okay, this is one molecules only, but one, two, three, four. Fourth acid is on the fourth carbon atom. Second acid. So in that, water molecule will be removed from the one molecule. That's why it is called as a intramolecular dehydration. So in intramolecular, this is succinic acid. The product is called as a succinic anhydride. And very important, this one, Gabriel phthalimide reaction. In that we are going to use it in the amide preparation. So that is very important. Gabriel phthalimide. Okay. Gabriel phthalimide synthesis used in the preparation of amines. So there, to understand that, before that you have to have knowledge of this phthalic anhydride. Okay. Phthalic acid on heating, what it will give? Phthalic anhydride. There you will use in the Gabriel phthalimide synthesis. Okay. So that is a naming reaction that is very important for but understanding that this reaction is a base. Okay. So then malic acid. Malic acid is this one. Double bond is there and cis, and if it is on the opposite side, then it is fumaric acid. Okay. Fumaric acid and malic acids are both geometrical isomers. Only malic acid can undergo dehydration to form malic anhydride, and glutaric Ohm's gap. Gap means total 5 carbon atoms will be there. It will also form the intramolecular dehydration to form glutaric anhydride. Very simple one. Okay. Okay. Next, if it is more than 5, that is 1,6,1,7. What is this 1,6? That means first carboxylic acid and second carboxylic acid is at the sixth carbon. Okay, 1 plus 5 here, sixth carbon or seventh carbon. Then they will form, these two key acids undergo dehydration as well as decarboxylation. They will lose CO2 also decarboxylation. They will lose H2 also dehydration. Both will be taking place and it will give the ketone. Okay. So cold synthesis undergoes free radical mechanism. Understood? This is very important directive objective. Okay.